Hello and welcome. The project you see on this screen is a simplified cement production mill. This project has 4 pages, which is the cement mill, which covers the vertical roller mill. There's also the material feeding page, but as you can see, I configured that you should access some pages were logged in. So we shall just log in here and we shall log in as an engineer. Okay, so we are logged in. So there is the material feeding page, and in this page basically we feed in the different kind of materials that we need in the cement production process. These materials are clinker, gypsum, limestone and pozzolana. So basically that's what's happening in this page. The other page, you have a PID view page. In this page it's just viewing the PID and its behavior. This page is the one that's using the PID to control the amount of product we want to get into the mill. Basically, that's it. I'll be explaining. Then the last page is the alarms page. And this is where, in case of any fault, you'll find the error here. As you can see, some of these belts have some tests like the BSS. This, in case the belt sways to the right or to the left, then you'll just know. So we can just reset. And when you come to the alarms page, you'll notice that there is an error here that says that material inlet belt has swayed, BSS error. So that's basically what the alarms page does, and you can acknowledge the error and it will just go away as long as you have reset it. This is our main page, basically. In this page, you can start the system. As you can see, it comes on. You can also stop the system. You can switch between manual mode and auto mode. So you can just switch between automatic mode or the manual mode. So the overview of this project, for us to understand, we have to start from the material feeding. So basically the product comes from maybe the yard. It's a simplified project. So we are starting from the material feeding side. So basically there's some materials that come into this belt, and you can either feed the clinker side or the gypsum side. So as you can see, this motor has the option to operate it in a forward mode or the reverse mode. You can stop it and we can just test. These are just tests. Basically, in case the belt sways, is the BSS belt sway switch. So when the belt sways to the right or to the left, this switch is activated and you can just reset it to remove it. There's also the pull code in case someone switches off the belt. We can just test it. So as you can see, it's blinking that there is an error. And also down here, you can see that there is an error here. Clinker and gypsum belt has swayed, BSS error. You can just reset it. You see it has turned green, so you have to just acknowledge it and it will go away. So the material comes through this belt. It feeds either of these hoppers. So you can just drive this belt in forward or reverse, and it can feed this belt, and this belt can go forward or reverse, and it can feed either of these two. This will depend on the operator. Also this one, you can feed it forward and reverse the way you just want it. The next is that these hoppers, now some clinker here, some gypsum, some limestone and some pozzolana, then feeds this main belt, which goes to the mill side for the materials to be grinded. We are using a PID controller to determine the amount of product you want in this belt. Basically, maybe you want a certain percentage of clinker, a certain percentage of gypsum, a certain percentage of limestone, and a certain percentage of pozzolana. We use a PID system to try to get to the set point. So I'll just show you what I mean by this. So in this page here, this is whereby we set our set points. Basically, the mill for now it's running at 310 tons per hour, but you can just change it maybe to 300 if you need it to be. It depends. Or if you want it to be a 290, you just can change it and it will update it. These ones are the ratios. Now, if we need a certain percentage of clinker, certain percentage of gypsum, you know, that way and that way. But for this, we shall not be doing it manually because I've provided a list of products you shall be grinding in this cement plant. Basically, we have a KP silver, which is kind of a weak cement. You use it for the normal construction. KP gold, it's somehow stronger than silver. You get the process, you know. KP super gold is stronger than gold, and KP diamond is very strong. In this page, you can basically select, maybe you want KP silver to be the product that you want to produce as the end product. So you just select it and you see it's telling you that KP silver is selected. So as you can see, our set points here, we want 52% of clinker, 3% of gypsum, 5% of limestone, and 40% of pozzolano. So these percentages are basically calculated according to the TPH, the total TPH that you want the mill to run at. So for this 290, if you do 52% of 290, it will give you this 150. And now it's fed here as the set point. So the set point of this belt is that it should be traveling at 150.8 tons per hour. So our PID will try its best to maintain this belt at the set point. The speed of the motor will be controlled by the PID. So the actual feed will try to always be at the set point, and that is achieved by controlling the speed of this motor. So the application is the same. So you can just select KP Gold. As you can see, the percentages are changing and the actual feed is also changing. You can pick KP Super Gold, you can pick KP Diamond, and you can just see that's basically what's happening here. You just select the product you want or the kind of cement you want to be your end product. So here it's just the same as the PID view, but we have few options. So you can just view the trend of PID. As you can see, our set point is at 150. If you check, it's less at 152. So you've seen as we change the set points, the black line goes up, you know. As you see, KP Gold, we need nearly 208. Yeah, if maybe for KP Diamond, you can see it has jumped. So this is basically the set point, and this red line is the speed of the motor, and there's also a green line which indicates the actual feed, this one here, that's trying to get to the set point. So we shall see when we start this PID. So that's all about this page. After the material are fed to this main belt, they go to the mill. So we come to this page. So as you can see, this is the belt that says from Wayfeeders. So from this page, basically, the material are fed here, and there are some rejects that goes to the reject bin. The fine material goes into the mill, and as you can see, our set point for the mill is 290. After the process of grinding is done, those coarse materials that are not really fine to be cement are sent back into this belt, and they go to this bucket elevator. This bucket elevator takes this material up here and it returns them to this belt, which in turn feeds the mill again, and the grinding continues. So we have a fan here, an 1800 kilowatt fan. This is a big motor that sucks that fine material into this back filter, and those materials are purged down here. So there is this motor that just rotates and allows the materials in an orderly way, because if that pressure just patches, it will fill this belt and overload and all those things. So this motor basically releases the material in an orderly way. So the material goes to this belt and then goes to this bucket elevator again and goes to the silo. This is the storage facility now. So those coarse materials again are sucked and they are returned to the base of the mill, which in turn are taken to this belt, and you know, they go back and the process repeats itself. So the PID is just the material feeding PID, basically. Yeah, so that's it. It has just more options, you know. You can print, you know, and you can just adjust the settings if you want, or configure new things here. Let's see the operation of this mill. So as I've said earlier, you can stop the system, you can start the system here. So we shall stop it. You can pick the mode you want to operate in. There's the automatic mode and there is manual mode. So basically in the manual mode, you have to start everything on your own, but in the automatic way, there is a sequence. So that sequence basically is that this back filter will start, this motor will start, this belt will start, and this fan will start. So that's the sequence. Then after some seconds, which we have a timer here, this mill will start. So this main drive of the mill will start, and the mill will start rotating and grinding. After a while, the rest of the belts will start. So this bucket elevator, this belt, this one, and even all the belts in the material feeding will start. So that's the sequence of the automatic mode. The manual mode, you have to do it one by one. by yourself. So we shall start with the manual mode, of course. Then we shall start the system. So our system is on. So you can start now your motors. You can just start that one. You see it's on. You can stop it. You can start again. You can try, giving it an error. As you can see, there is a blinking that indicates, hey, there is an error in this belt. And to know that error, you just come here and see that, hey, the material inlet belt has swayed, BSS error. So you can reset it. If it resets, that's good. If it doesn't, you just send a technician to go and check what's happening there. So that's the auto mode. So we can just start several belts here. Yeah, you see that belt is on, the indication. We can start the bucket elevator. We can start this one also. We can just start everything manually. We can start the back filter. So basically here you can just start everything. So as you can see, the temperature is increasing. This is just a simulation. When the mill starts, the temperature obviously goes up. And for this project, when it reaches 80 degrees Celsius, this motor will go off. It will just go off automatically. As you can see, the silo level is increasing because, hey, there is some, grinding going on. There's some sucking going on. And there's some material going into the cement silo. That's all about the manual mode. We shall go and stop the system. So as you can see, the stop button just stops everything. Let's now try the automatic mode. We are going to start the system so it's on, and we want to pick the automatic mode. So as you can see, the back filter is on. This one is on. All these buckets are on. And we are waiting for this timer 15 seconds for this motor to start. And you can see there is a siren that, tells the people to get out of the mill side. So it's off. Now our motor is on. So we again wait for this timer, which is also 10 seconds. Yeah. So as you can see, all the belts are on now. Our feeder is now watering, as you can see. So you can just view the trends. As you can see, this was our set point, which is 208. Here it is 208, and our actual feed is 200, and it's trying to get to this 208 basically. As you can see, it's going up and up and up and up. So this is our PID. Our motor went high, and this one went also high at a very quick rate. Then when it was about to reach the set point, our motor speed started going down, and it's trying to get to this set point and stay at the set point all through the production process. So basically that's what's happening here. You can view the trends of this one too. As you can see, this one had some overshoots, but it's now okay. The set point for clinker is 208.8. You see our actual feed is 208.79. For gypsum, 14.5. So you can just pause and see everything going on here. So if we select maybe something like KP diamond, that's all that's going on in this page. It's basically us trying to balance the amount of material we need according to the cement type you want. Of course, you can stop a certain motor if you want, and you can start it. You can test BSS or something like that. So as you can see, this yard material belt has swayed. So this is the belt. You can see the indication that there is an error. So you just reset it. If it doesn't reset, you just send an engineer to the field. So you can just start the belt again. That's all about this project. Thank you for watching. I have attached all the code that I used for this project. The project was done in a tier portal. That's a Siemens software. Yeah. And this PID was done using WinCC Explore version 8.0. That's also a Siemens software. So basically this project was done entirely on Siemens softwares. So I'll be posting all the code that was necessary and giving a detailed explanation of everything, because this video is just an overview.